Hello and welcome everyone. We're really glad to have you here today for the next session in our Day One and Beyond series, which is taking you through a series of topics and activities related to building out on Oracle Cloud. For those of you who might be new to these events, we're hosted on Cloud Customer Connect, which is our Oracle community forum for end users. And I'll be sharing some resources today that will bring you back to those forums. If you are not already a member, we invite you to create a free account, join in discussions, post your questions, and look for upcoming events on all kinds of topics. My name is Kenna Kettrick. I'm a program manager with the OCI Go-to-Market team. And today I'm joined by the original Day One and Beyond team, Jeremy Walker, Master Principal Cloud Architect, and Larry Beausoleil, Cloud Engineering Senior Enablement Manager. They're going to take us through how to start a 3-tier application in OCI. All right, I think that is quite enough from me. So Larry, go ahead and take it away. It's all yours.
Awesome. Thank you, Kenna. Welcome everybody to our Day One and Beyond, starting a 3-tier web application. Or just in general, a 3-tier application. Like Kenna said, my name is Larry Beausoleil, and I am joined here with Jeremy Walker, and he's working on a couple pieces to the demo as we're kind of talking through some stuff. So I'm gonna start the intro, and then we'll dive into the console. So it's gonna be very much a short conversation. A couple of pieces that you've probably seen consistently throughout all of our Day One and Beyond track is all of the offerings that we have here for our cloud service, and the fact that we have a full stack solution capability. So you can go from low code, you can get your security implemented, you have your monitoring, logging, analytics, and the stuff is evolving each day. As you look in the console, things change, new features come out. We have a blog on new features and items there. So keep an eye out on all of the stuff that's coming up with all of our products. One of the things we're going to focus on when we're talking about building a 3-tier application today, though, is we're using Terraform to build this. And this is something that can be done as a manual process. It doesn't have to be, you don't have to use Terraform, but since this is something that's more of like a deep dive, this is something that's coming off the backside of talking about, cloud adoption. We've talked about operation in the past in our Day One and Beyond series, and we'll be talking about operations going forward. It just makes your life easier to actually use infrastructure as code to at least start things off. And there are a lot of templates out there. If you haven't seen it, we do have an architecture center, and we'll be looking at a little bit of that today as we kind of build this out. And the standard items for a 3-tier architecture, you have maybe compute, you have your database, you have a load balancer, and in some of these components, we also have security we have to think about. We have, where's the traffic going? What are we blocking? What are we allowing? How are we getting to the application from the front side? Where's our DNS? There's so many different components to actually build this out. And then there's a lot of different ways that you can actually build out a 3-tier architecture. You don't have to use an instance. You may be doing this as a cloud native deployment. So you have some components, and maybe you're using Kubernetes, maybe you're using functions, maybe there's a lot of different services that we have that allow you to solve this particular problem. And I wouldn't call it a problem. It's just, how do you build out the application the way you want, and what's the performance you're looking for? So there's a lot of questions you have to think about. And along the way, when we look at these questions, some of the parts are, what is your responsibility when you start building these things out? When we look at some of the services, we kind of progress over, is it infrastructure as a service? Is it platform as a service? Is it software as a service? And what are we utilizing? And so if it's a fully managed service offering from Oracle, you have less responsibility. You have less things that you need to worry about. At the end of the day, you're always concerned about your data. You're always managing your data, making sure that you have redundancy built in, and your access to what's going on there. But if you go from on-prem into infrastructure as a service, this is something where you're looking at virtualization basically up. So there is a hypervisor there. Now there are some lines that kind of move or progress, lower or higher depending on what that service is. So let's say you're using bare metal for your services for your 3-tier application. And that's something that you're going to have direct access to the host via API calls, and you're going to launch it the same way as you launch a VM, but you can actually put, an OS on it, through the API calls, build it out the way you want, put a hypervisor on it. There's a lot of options for that. So this is just more something to keep in mind as you look at building out. The next piece, when you're starting to build out your applications, where are you building out your application? I've talked to a lot of different people about this in the past, different customers. What are your restrictions for your application? Are you building out a three-tier application that you're going to be accessing globally? Are you going to be distributing this application to multiple regions because you want to get closer to your customer base? There's a lot of other layers. So we may have a load balancer in region in front of our instances, but what about if we have that application deployed in Phoenix and Ashburn, and then we can do something with DNS load balancing? And so we have a way to distribute that traffic between those based on geolocation, based on latency. There's a lot of different ways to configure that so that if you have a customer that's, let's say, in California, they go to the Phoenix region as opposed to going all the way across to Ashburn, so that you can increase that performance, that capability, by reducing latency. But we have a lot of regions. This is expanding. We do have a map on the website that you can take a look at, where we're at, what's deployed. And the other thing to keep in mind is, these regions are a collection of availability domains, which is also a collection of fault domains. So you can really get that high availability in your application. All right. So our last slide here before we kind of pull up the console and walk through it as much as we can, and pull up some of the components and the security around it. This is a 3-tier application, 3-tier architecture. Now, any of you that are just starting out and want to build some of this out, a lot of these designs and stuff, there is a site you can go to, our built and deployed site, and we have a template so you can actually start, throwing your icons where you want and kind of figuring out, what am I trying to build? What solution am I trying to create for our application? And the start to this is, how do we actually get into this? So we have our internet gateway. And if you've come to our networking talks in the past, we talk about how a VCN is created. We talk about our subnets and public and private subnets. And you'll notice here that we have a public subnet for our load balancer. We also have a public subnet for our application, our web tier. And this is going to use auto scaling. So this is another thing to consider as we build out. What are the other capabilities we need or functionality? Is this something that we are, we're scaling horizontally and to meet the demand of the application? And what components do we need to consider? Our load balancer capability can scale, and we can have a flexible load balancer, or we can have a fixed load balancer. And then we have the capability of essentially a layer 7 load balancer and a layer 4 load balancer. So depending on the type of traffic that you're trying to send to your web tier will dictate which load balancer. Now, from the start to this, you also have to consider, are you going to put your cert on your load balancer? And that can be a good idea, because the load balancer is going to scale. And a lot of times it is required because you have to have end-to-end encryption in your application. And so when you're putting that cert on the load balancer, maybe you have to have a cert from the load balancer to the back end. And then this is where we start talking about what traffic is allowed between each tier. Because when we, the security is something that I love to highlight in every single conversation I have, because it's so crucial in this day and age. Protecting every layer and making sure that it is isolated from the internet as much as possible, but still giving you the performance you need, because you don't want to irritate your developers and your database engineers with some of the security, but you also want to implement it as you're building out. So we have our NSG, and that's different from a cert. So we're putting a cert on a load balancer. We may have a cert on our backend web servers that we're going to scale horizontally. And then we would have our NSGs. Now, a network security group, this is going to isolate for the specific resource. So if we look at the load balancer, we're putting that at the load balancer level to say, this is the traffic that can communicate in this subnet for this resource. Now, if you want to talk about what do we do at the subnet level, that'd be a security list. And a security list will allow us to put rules around our public and private subnets. Something to keep in mind as we're building this out is NSGs and security lists are looked at as a whole. So if there is an allow in there, let's say we open up port 443, and port 443, for those that haven't seen that or haven't experienced that in the past, that is HTTPS. It can be considered a secure port, but that all dependent on if you configure it that way. I know a lot of things have changed when we talk about security ports and all that, but we can open that up at the NSG, and then you're looking at the security list and the NSG, and it says 443 is open to that resource, so it is open. Then if we go down to our next layer, we have a NSG for our web server. In a lot of cases, we're going to have an NSG that says, I'm allowing traffic from the load balancer to the web server, and that's the only traffic that's allowed. It still has access to the internet because maybe these particular web servers actually need to communicate to the internet. Maybe they're finding a location, or they're having to get responses back. There's other ways to do that. We don't have to have our web servers in a public subnet for them to be able to access the internet or respond. Again, this is going to be something that's dependent on the application you're actually deploying as to, does this need to be public or private subnet? And then as we go down to the private subnet, our database should be in the private tier. This is something that we want to protect this. We want to isolate this. In this case, we're going to use ATP, Autonomous Transaction Processing Database. And this is something that there's a couple different ways to deploy it. But with that said, enough looking at this particular architecture here. Let's go ahead and Jeremy, we're going to pull up the console and kind of take a look at what's going on in there.
All right, good deal. Yeah, I'm still frustrated with the demo guides today, and I'm working through it, but we'll be able to demonstrate what we're trying to do and show you how you can do it. And I'm working with actually some pull requests on the back end to get this working so that you can try it at home. But yeah, let me show the console real quick, and let's see where I'm at. So I'm showing the right screen. Yeah, here we go. So yeah, should be familiar with the console at this point. This is what you would see when you log into Oracle Cloud. One of the things we want to point out to draw parallels with what Larry was just saying is we have this idea of quick starts to get you going with a lot of the concepts. And specifically, one of the quick starts that we bring in is exactly what Larry was just going over with this highly available the highly available 3-tier architecture. So from your console, you can click and deploy through this quick start. It'll build out the VCN if needed. If it's already present, then it'll take advantage of the network you have in place. And then it'll build out the load balancer, the security groups, script up the ATP, the autonomous transactional processing unit with an autonomous database behind it. And so you can see how all of this works together. Now, most of this I have pretty well built out. This is our network visualizer that you can use. And you can see that in this region that I've built out this web app, I have built the gateway and the network, the NAT gateway going back out, and then some security lists as well. And this is all things that are built for you. The security lists are around these subnets that are built out to divide up the routing. As Larry says, you want to divide out what can get network access and what network access can be available per subnet that you have here. And each subnet is built out with the routing table, and that routing table defines where packets can travel. This is the internet gateway, so what we call a DMZ. DMZ allows network traffic to anywhere, from anywhere, to come into this this subnet. Now, we don't want that necessarily for, obviously, we'll say, our private subnet. Our private subnet is going to have strictly limited ingress, to say, only out to our NAT gateway, nowhere else. You're gonna have the concept of it's not, unless you get traffic from somewhere local, you're not going out anywhere. You're going straight out to the NAT gateway and not through directly to the public the internet directly. And the same thing with data. Data's the concept of a data subnet is going to give us basically the route table is going to say, if you want to go anywhere, you're going anywhere to only the public or only the other subnets within this configuration or within this network. So I think I think one of the things that Larry was talking about was, why you want to build that out. And so physically, as you build that out, you don't want any traffic in the public internet to have direct access to your data tier, and you don't want any public traffic in your DMZ to have access to your data tier as well. So you use this 3-tier differentiation to build out those lines of demarcation between all of your tiers. Now, something that's will be built out, it actually uses Terraform in this quick start that I pointed out. I'm going to switch over and we're going to see actually, let's look at here. It'll actually look prettier. This is publicly available. It's not something that's just on my machine. We have a GitHub repository for all of this code that you can deploy. It builds in all the scripts to build out the database. It builds out networking scripts. It has some pre-populated data sources and an app to actually demo all of this out. And so you can come in here and download this, clone it, configure it yourself, or this click here takes you directly to our resource manager in OCI. I can show you that here so that you can deploy it using our resource manager. So let me get the cloud name. I'll steal it from here because I don't exactly remember exactly what it is. And what this is like to do, again, from that GitHub repo, you can directly deploy this 3-tier architecture into your tenancy, given whichever compartment you would like to deploy it into. Set the terms. I'm not going to say test. I'm going to say demo 3-tier. Let's put it in. Let's just put it in the day one and beyond.
I'm gonna make one.
Oh yeah,
Jeremy. Yeah, we got a bunch of items here. I know okay. This isn't quite a Terraform talk or resource manager talk, but when we look at the Terraform version, this is something to keep in mind, because depending on when you deploy it, there are some syntax changes for the OCI provider and for Terraform itself. So just kind of keep that in mind when you're looking at some of these. So they may be a great Terraform template, but I know I've written some in the past and I'm like, why isn't it running? It's like, oh, syntax changed slightly. So, with any code scripting, anything like that, the syntax may change. So keep that in mind as you look at this.
Yes, exactly. Yeah, and this did recently change. I think we came up through 12 was previously supported. 11 was dropped, and now we're I think we go back to 12. So we're trying to get everyone up to the 1.0, the most recent version. But we do support actively back to 12. And HashiCorp does a good job within Terraform to make upgrade options available, so you don't have to go back and rewrite a ton of code. So typically there's several reasons, mainly around security, that we drop support for certain versions. Like I said, we go back to 12, which is, I'd say, 5 or 6 years old now. But there's still a lot of code out there that uses it. But again, we try to keep it as up to date and support as many that are actively supported within HashiCorp as possible. And then, as Larry mentioned, this whole stack is backed by Terraform. This is just an interface over a Terraform managed, or Terraform delivery or build managed service that we have called Resource Manager. I'm gonna, this is just plain text. I'm gonna give a bogus thing here. Oh, good. See, does it meet? It does not. I gotta be better.
Password complexity always gets me. Oh. I use random generators.
I might have to do that myself. There we go. And with that, it gives us this, this, where is it going? What you would see, this can run apply immediately, which, if you're familiar with Terraform, run apply versus run plan. Run plan would build out the feasibility. What is it going to put into your environment? Run apply actually goes ahead and starts building out the resources for the environment, and we can actually watch that happen. No, don't say. And so this is actually issuing a build job for this 3-tier architecture. Now I want to jump out. And so what this is actually doing, talk about what it's building out. It's building out this VCN, this network topography here with the 3 subnets and the security layers in between. What it'll then, it allows you, it's going in and building the load balancer with the failover in its own NSG, the network security group, and then the web servers in their security group, and then the database itself on the back end in its security group. Again, Larry went through very well the reason you want to divide these up. And the thing to key off of here within OCI specifically, what we're doing here, and I'll show in the Terraform itself where we pick this, we say that we want these scaling web servers to be in different fault domains within this AD. What does that give us? Yes, it's a 3-tier architecture that gives us that security between your data and your front end. But when you're scaling, you also want that fault tolerance. You want the fault tolerance within the application. Let's say the web server itself goes down. But also the key here is, the worst case scenario is the provider. You have this on-prem with power failures and instances go down. Well, there's physical entities under the cloud. Your cloud provider itself, OCI, is no exception. And so if there's an issue with security, with a network blip or a power blip, our fault domains within our availability domains have separate power and network sources for each fault domain within the same physical building. And so what this does is it keeps you fault tolerant across your application, but also within the externally to the infrastructure that host your application as well. So this is something we suggest doing in best practices, but we also facilitate doing through automated processes like Terraform, through scripting in the CLI and things of that nature. So that's something that we want to make sure we point out through this automated process, that we take advantage of these tools built into the platform to keep you fault tolerant, highly available, and secure. Go on to say, there's no charge between fault tolerance for traffic. That's something that within a 3-tier architecture you don't hear much, but when you get into high performance computing, when you get into things like AI and ML jobs, where you have hundreds of servers that are going to be crossing this availability domain. In other providers, in order to get that high availability, in order to maintain the fault tolerance, you have to place resources across these availability zones or these inter regional constructs. Within OCI, you have that within a single domain so that you don't pay the latency costs to go between the availability zones or the regions that are defined within the other providers. So you can have super low latency, super high performance computing that you experience on-prem, especially if you're running something like autonomous database, or if you're running even Exadata takes advantage of this as well. You get that performance and expectation and still have the availability, still get that the word I'm looking for escapes me, but the you get the SLA. There we go. That's the word. You meet the SLAs for availability for your auditors and your compliance regulatory bodies as well.
Well, then, and
okay, go ahead.
The other piece you're kind of talking about in that architecture that you're showing, you can pick the fault domains that you want in your AD. So, talking to that point a little bit, when you're building out this application, you can have it in one AD and one fault domain if you really wanted to. I don't recommend it. It's not best practice, but depending on the application, if that's a requirement for what you're trying to do, you can select that upon deployment of these services. So when you're building out your Terraform, or even doing this as a manual process, you can say, I want this in AD1, fault domain 1, and deploy everything. The subnets, you can have the subnets span the ADs, or you can have a subnet be AD specific. So that's something that you can have regional subnets. So just things that you want to consider as you're doing this, because we have a lot of versatility when you're building out your application.
Yeah, exactly. And then even we extend that more within this 3-tier. I know we keep referring to this 3-tier. I'm making a mess over here. We extend this 3-tier, saying that you have your front end, your application tier, and your data tier. But again, we're talking about cloud. That concept deployment is still kind of legacy. The idea of, okay, you have your load balancer, you have where your work's done, your data. But what you get when you go to OCI, go to cloud, is this thing that's kind of easily overlooked. Your load balancer has this scalability horizontally as well. So as this group, as your user base increases, your load balancer, which is, we call it flexible here at OCI, your flexible load balancer increases its capacity as your demand increases, and then again shrinks down as demand decreases, so that you don't have to worry about deploying that on your own or managing it. You can set your rules and your scaling options to have the failover, but also your flexibility to scale up to meet that demand. Have the same thing, your auto scaling to your own web. Again, it's become standard within cloud best practices, but it's something that, again, within this automation, as simple as a 3-tier architecture, and then again, as complex as your multi-tiered enterprise scale architectures, your scaling goes directly into controlling costs, so you can scale up and scale down as demand determines, but also you scale in the construct of availability. So you make sure that as you scale, you meet your SLA demands. Going down to your data, autonomous is another tier. You have to have the ability to scale to meet the demand as the other 2 tiers are scaling. Autonomous database, you have things like RAC and things like XACS that scales to meet that demand as well. So within your 3-tier architecture, your 3 tiers are moving, expanding, growing, shrinking as your workload does. And because you're taking advantage of these managed services, there's platform features like scaling, you just sit back and relax instead of having to be on call at 2 in the morning or 4 in the morning on Black Friday, getting ready for these events. Your platform is doing all of that work for you. And again, it's seen it simply put within these 3 constructs. You can add and detract from this as you will, but it really does highlight these features of the platform. Let's see if I can see where and then Larry, do we want to do, I know we've talked about the idea of the load balance network the load balance, the servers, and the database. Are we overlooking anything within the network topography as well? I don't want to skip anything that's highlighted there.
No, I think we kind of covered networking. I mean, I guess the little bits of you can have, instead of having a public subnet for your web tier, you have a private subnet there, and then you have a NAT gateway for accessing externally. So there's a couple different ways to do that. So
And
when you
yeah. Oh, go ahead, Larry. Let me fix this.
I was going to say, yeah, I mean, this is a great troubleshooting thing. Like, so we launched the Terraform, and this is something that I've experienced often where, it's like, what did I forget? What did I mess up? The nice thing is in the logs, like we can actually look back and see, what's going on, what actually caused this to fail so that we can get this up and running. Now, one of the things to keep in mind with Terraform is a resource manager is it'll stop at the failed point. So if it launches any resources, then those resources are already launched. So we should have a couple of resources, I think, launched or created, so we can actually take a look at the load balancer. But at the point at which it failed, and then we can reapply it, and it'll say, hey, these things are already done. And then it'll just add the rest of the components that we need for our application to get it up and running. If we want to destroy it, it'll destroy all the linked resources as well. So it's a great way to clean up. It's like, hey, this Terraform didn't work. Let's roll it back. Let's clean it up.
Yep. So yeah, so like you mentioned, we have the load balancer that was created, and it's actually waiting on this job to complete. And what it's actually waiting on is my I have another job that's running in the background that I actually stole that resource for and named it similar. So I'm going to destroy it so that hopefully we can get back to the job, re-establish it to the state that it was in, and kick it back off, because that's one of the benefits of running the Terraform aspect of it is it keeps that state so that you don't have to start all over again.
Yep. And you can download the state file, you can look at it, you can, and then re-upload your Terraform, see what's changed or make modifications. And just kind of a word of warning, if you're using Terraform to deploy something like this, make sure you consistently use Terraform to work with and or manage what you're doing. When you start modifying it outside of Terraform or outside of Resource Manager, it's possible, and there's ways to pull in current configurations, current state, but it makes it a little bit of a mess. So it's better just to use Resource Manager, use your Terraform, upload that. So.
Yeah, so what I'm going to do here is go back and we're going to do the stack again in a cleaner compartment, because that's what we'll hear. What I can go back and show. Let's look at that. So what I did here is, this was where I kicked it off before, and what we're seeing is I'm in my rush didn't request is still running. Let me stop it. In my rush, I didn't clean up after myself, which was the problem. So let's go back and try this. Where are we at? Here we go.
There you go. And the nice thing is we have a template to start from.
Yep.
So this is something that, and you don't have to, like, you can go in. I don't know that I've ever written a Terraform script from scratch at this point with all the Terraform scripts that are out there. It's, let's go find one, pull in the information you need. I need a VCN. I need all of these pieces. You can grab it, pull it in, create it, test it. And that's part of this process.
Yeah, I'm going to kick this off, and I'll actually show what the code behind this actually looks like when I'm kicking it off on the back end, and see how it's deployed, what it looks like. And because you can, like I said, you can do this on your own, and it's using your own build server and managing your own. See, what is it? There we go. It does not like my password decisions today. I'm gonna cheat, I think. Safety is always a priority, but sometimes it does frustrate me a bit.
That's the developer side of you coming out.
Yes, it is. It's just it's one of those. There we go. All right. Oh. Okay. Compartment. Yes. All right. So actually, so what this is kicking off. Yes, job is accepting. Let me jump over to where we can actually go through this script here. So what I had done before, and this is actually where there's an issue that I'm having. I'm actually going back and forth with an internal team of ours. There's a bug in a script that we released a new version of one of our products, and we need to go back and update a variable in the script. So that's something that we'll fix in the short run. But we do lay out how to deploy this. You can do this, like I said, with deploying it to the cloud with that one click, and that's the interface we were just looking at. But you can also do it through either Jenkins or through, on your desktop through Microsoft Code or Visual Studio Code or through the CLI. Familiar with cloning a GitHub repo and then going in, setting these, which this is something that may look interesting and maybe new to some people, is the way that OCI authenticates from the command line. You need your tenancy, your OCID or your Oracle Cloud ID, your fingerprint, which is derived from your key, and also your private key path locally. So you need all of these set up in order to interface locally from your machine or from the server you're running this from. And then this should look familiar. This is the password that I was having so much trouble with. It's provided as a variable. And then the region and the compartment which you would like to deploy this into are variables that you would need to include. So this is really the only prerequisites you need to kick this off. And then from there, if you're familiar with Terraform, you're familiar with these are, you initialize the job with Terraform. Basically, Terraform downloads everything it needs, sets it up to run this code. You plan, which is it's a dry run, if you will. It dry runs the deployment, shows you what it's going to build out, what it's going to apply, and then when you do the apply is actually when it builds the resources out in the environment. The great cleanup part with Terraform is and the scary part is destroy it. Actually, within Terraform, it knows what you built out, it keeps up with it, and then we'll remove those resources when you're finished testing it or building it out. It's a very useful tool for cleaning up, especially within cloud, where one of the benefits of this is you just want to see how things work. You want to build it out. You don't want to go clicking through and trying to find everything that was created when you you're playing around with a new feature, a new service. If you do it through Terraform, through automation, then it builds it out, keeps up with it, and then you can destroy and clean up so you don't have any virtual technical debt left when you're done. So let's see if I'll actually go through. Where'd my screen go? There we go. Apologies. There we go. So wrong screen. Too many screens up. There we go. Yeah. So within let's see here, within Terraform, this is what you should see within. Here's the files extracted. You have the code that was downloaded. When you run your init, and then I'll run it here. If you run your Terraform init, it's going to create, let's see, this temporary Terraform folder. I can go ahead and destroy it and start from scratch. But if I do that tf init, what you'll see is it's going to go out and provision. Let's see here. Yes, I did mean init. Thank you. It's very helpful. And it's going to go out and download all the modules on my behalf that I need to actually build all this out. Again, something that if you're building this by hand or through the CLI, you need to make sure you had all of this on the back end. Terraform does this for you through its construct, through its framework. Yep. And so it's done all of that for me. Now what I can do is that next step is the Terraform plan. And this plan exactly is going to go out and make sure that the environment that I'm building out into is ready. It's going to pull out all the prerequisites. Yeah, so it's going to add, that was pretty quick. It's going to add 36 resources. And we can look at those resources that it's going to build and what it does on your behalf. Some of these are let's see. Go at the top. So yeah, it's going to build out my instances and the region that I want. And a lot of these things that you'll notice, the platform does for you, but you can also overwrite some of these if you have network requirements that you want to assign IPs. It go ahead and pre-provisions the availability zone and scales it out across the fault domains that I have requested. It provisions the software. There's also scripts that it runs that are going to run on the instances after I've deployed them. All of this is done within, like I said, within this framework, within the launch options and scripting to build out the versioning, connect to the database, make sure the database connections are up and working, and then also configure my scaling rules that I mentioned before. Here's the instance pool and the scaling rules. Attach it to the load balancer so that it initializes with two instances initially, and then can grow. Those are things that you can build, set and forget it with these with Terraform. So with all of that, and this is where fun starts, we actually say tf apply, which is going to have some problems because this is the exact same process that's run from that interface that we saw in the console. This code, this backend, these inputs are run from the console on your behalf in Resource Manager. So if I run this here, it's running duplicates and it'll have some conflicts like that as we saw before. But it's the same thing. There's no special sauce on the back end other than it does take the permissions information from who's ever logged into the console. That's a step that you don't have to use. That tendency in compartment information you saw, the user aspect of that is taken from the person that's logged in and executing from the console. let's go back.
If we pop back into the console, we can see what we've created. And one of the things to keep in mind, like you see these plus marks on this Terraform, that means it's getting created. If you see there's different pieces when you do the plan, they'll tell you, oh, this is going to be a new creation, or this is going to be a plus minus, which is a delete and then recreate, or this is going, there's a couple different, if it's going to get destroyed, it's going to be a minus. So you have a few different items in Terraform that kind of help you with this. If we look back at this one, it looks like we have.
So yeah, we can go in.
Yeah, we can see what's going on here. So if we look at the logs, we should be able to see what's.
So this, yeah, failed. You can actually see what was built out here. It's all the, say, build everything out, and then to create the autonomous features of it, CPU scaling, blah blah blah. Context. 403 permissions error. Now that's interesting.
Yeah, we may have.
Oh man, I have made somebody in the demo-verse upset today. And Larry, I apologize for that, because that's something that should have had beforehand. But it is something that. Let's see.
It happens in this, you do a demo live and you're like, well, but now it leads into like a troubleshooting process, and we can look at the logs real quick, and we know that this is a perfect spot for me to kind of talk about how do you actually, if you're not sure where to start, how do we open a support case correctly to make sure that we have all the information. So you'll notice that a couple of things that we want to grab for this. We can grab the log file. We can grab the OCID at the top for this particular job here. We can grab this information, and then we can send it off to support to say, hey, this is what's going on. What are we missing? We can also look at the Terraform. We can re-upload a new configuration for Terraform. I'm leaning towards most likely in this particular account, I don't have certain capabilities of launching free tier autonomous because the type of account tendency that we have here. So that's gonna cause some issues, and it's making sure that you're looking at the correct syntax and what it's actually pulling for the variables. And this one is asking for a always free tier autonomous, which is going to be one of the reasons why this is actually failing in our account. And it's an easy fix. We can pull down the Terraform, we can update that, then we can reapply it. But we're a couple minutes away from the 55 points, so I want to make sure we don't run over today.
Closing out, and this is something that I want to stress. Don't let this discourage you. Don't let my ineptitude discourage you from trying this on your own in your own tenancy. This is something you should be able to go out and sign up for. You should be able to sign up for an account, OCI account. And like I said, a lot of this is free tier. You can select the free tier options for this, the free tier options for this, and try this on your own, build it out and see how it works. There's some nuances with our accounts internally, and like Larry was saying, what can be built out and what can't. But it's something that you can work through it. There's a lot of really good information here to guide you through it, and also let you go through it on your own to build out the code. You go in, change the CPU size, test the scaling, run. There's a great open source product, and there's some paid for as well that allow for load testing and testing the scaling, like bees with machine guns is one of my old favorites. To see how you're scaling out, how the scaling works across your tiers, see where your bottlenecks are. This is a great tool and a great starting point to show, hey, how does scaling work in the cloud? How does the load balancer react to traffic? All right, when the load balancer scales, how do my applications on the back end respond to that influx of traffic? Are they scaling at the right parameters? Things like, is it memory is my bottleneck, or is it network traffic, or is it IO? Things like that can be fleshed out going through these steps of dividing out where all of your entry points and your connections, your couplings are between your tiers, whether it's 3, 5, or there's a great omni tier customer I had where it's just hundreds of different endpoints and ingestion and egress points that all have to be basically broken down in the same way. Where is the traffic coming in? Where's it being processed? Where's that process? What are the dependencies on that process, and how do we get it back out securely and efficiently? And like I said, this 3 tiers, the perfect place to start testing.
Yep. And one point you brought up there is tools to actually kind of do a load testing of your application. Something to keep in mind when you start load testing applications. Verify. You may want to reach out to support and just let them know, because bees with machine guns is if you look at it, look how it operates. It's a simulated DDoS attack to your application. So be very careful about how you use some of the testing tools. There's Apache bench test where you can actually send concurrent sessions with a packet size. There are a bunch of different tools to make sure that it's operating the way you want it to operate and handling the traffic that you deem it should be able to handle for what you're trying to build out. But just keep in mind when you do that you definitely want to, talk to Oracle, talk to support, and basically say, hey, I'm going to be load testing my system, so that you don't run into any issues there. But with that said,
that's a good point, because kind of even speaking to that, there's a lot of things that we do on our customers' behalf to make sure that they're not getting DDoS. So yes, that's a great point to reach out and say, hey, we're testing our this account, or even say, hey, I got this build or this quick start off y'all's site, and we're gonna put it through its paces, and just make sure that we don't think that you have a production workload that's getting attacked. And so that's a great point there, Larry.
Yeah, awesome. Well, with that said, I'm going to hand it back over to Kenna to finish it off for today. So thank you, everybody, for joining us. And it was when demos work, it's great. But every now and then we have a demo that gets a little bit buggy. So, but it's okay. You can build, destroy, and recreate it, and that's the joys of the cloud.